Okay, let's try that again. Hi, everyone. My name is Cynthia Emerson, and I'm the DAIR Program Manager. Also joining me from Canary today is Tom Vitez. He's our Senior Director of Applications. Don McCullough, the DAIR Solution Architect. Eric Bitmanis, our Business Development Specialist. And Annie Jolicoeur, our Program Operations Coordinator. So again, thank you for joining us today and attending our webinar. This is one in a continuing series we host for our DAIR community. This webinar is being recorded and will be made available online. We would also be making available a copy in PDF version for you as well. If you have a question during the presentation and you would like to ask, please go to our participant menu in Zoom and raise your hand, and we will gladly unmute you. Also, if you prefer, please go to the Q&A at the end of the presentation or when we're asking if there's any questions, where you can use that section to message us directly with the type of question you have, and we'll answer it from there as well. As I said, we are recording this presentation and it will be available on YouTube. And Annie, if you'd like to do the introduction for us in French. I believe Annie is also having mute issues.
Oui, bonjour, j'ai perdu mon petit texte, donnez-moi 30 secondes. Alors, bonjour, mon nom est Annie Jolicoeur, coordonnatrice aux opérations de programme chez Canary. Au webinaire aujourd'hui se joindront aussi Cynthia Emerson, qui est la gestionnaire de programme du nuage de la TIR. Également avec nous, Tom Vitez, directeur principal des applications, et Eric Bitmanis, spécialiste en développement des affaires. Bienvenue et merci à tous de participer au webinaire de la TIR d'aujourd'hui. Ce webinaire est l'un d'une série que nous prévoyons organiser tous les trimestres. Ce webinaire est présentement enregistré et il sera disponible en ligne. Nous mettrons également à la disposition des participants une version PDF de la présentation d'aujourd'hui. Tout au long du webinaire, si vous avez des questions, s'il vous plaît, utilisez la fonction « Lever la main » de votre menu de participant Zoom et nous vous réactiverons au moment opportun afin que vous puissiez poser votre question. Vous pouvez également utiliser la messagerie « Questions et réponses » du menu pour soumettre vos questions à tout moment et nous y répondrons à la fin de la présentation.
Wonderful. Thank you, Annie. Merci. So our agenda today, we've got a couple of quick updates for you, and then we're going to hand it over for our presenter today, Peter Heath, who's joining us from CENGN, and then close with an opportunity for questions, answers, and closing thoughts. Next slide. So it seems like a pretty small announcement when you see it's a half a slide, but it's actually a pretty big one. We are delighted to announce that we have selected 4 companies in the community to build us new booster packs. So for those of you who would like to learn more about booster packs, of course, please check out our website. But they are something that we have been providing for our community. They've been really well received, and they're a get start guide, if you will, that comes with documentation. It's a resource collection of resources that is the documentation and sample solutions, sample code in a variety of emerging technologies. So as I said, if you haven't checked them out, please do, and look forward to 4 new booster packs coming for you. So the first one is on smart contracts. It's a blockchain DLT with Hyperledger Fabric, brought to you by Ecosystems Informatics. A cloud-based platform for geospatial intelligence with machine learning, brought to you by Ecosystems Information. An automatic static and dynamic application security testing booster pack, which is being brought to you by Parabellix. And advanced data analytics using AI, which is brought to you by Intellis AI. Look for, if you're on our mailing list, you'll be getting soon a lot more detail about what these booster packs are and a little more of information on what problems they're going to help you solve and what education they're going to help you and your teams with. So stay tuned. We're really excited about these 4. And just a reminder, we still have 11 spots open for our mandate to provide these. So if you are interested in learning more about how you too can become a booster pack builder, please reach out to me directly, and I'd be happy to discuss this further with you. Our other quick update for today is, as folks on the DAIR community email know, we are working through a DAIR Cloud upgrade right now, which will allow us to bring out new features, new functionalities for you. We had sent out an original email just advising you we are still working away on our cloud upgrade, but do look forward to checking your inbox if you are a DAIR participant currently about what we're going to need from you in terms of the migration from the current environment to the new one. But we're very excited to be getting through our migration and our upgrade, and look forward again to sharing more information in the near future with you about that. So those are our 2 big pieces of information for today. But again, as always, if anyone has any questions or would like more information about the DAIR program, please reach out to me anytime. So the main topic today, the main agenda item, is we are just thrilled to have Peter Heath joining us. Peter is a senior manager for training programs with CENGN. He spent over 2 decades in ICT-based higher education and commercial training, teaching courses at all levels, developing commercial training content, and leading programs in both college and industry settings. On a personal note, Peter enjoys all kinds of technology, all kinds of sports, and many years ago earned a PhD in mathematics. So again, we are just delighted. We've also, not just today, but we're delighted to also tell you that Peter will be joining us again in February with another in this series. So thank you, Peter.
Thank you very much, Cynthia, and hello, everybody. Bonjour. It's great to be with you this afternoon. If you give me a second to share my screen and make sure I'm sharing the right one, then we'll be able to jump into our main topic today. So, Eric, can you see my screen?
Yep, looks fantastic on my end.
Awesome, thank you for that. So yeah, we're going to talk about infrastructure automation, and specifically some thoughts on choosing automation tools. So in terms of an agenda today, I do want to give you a brief overview of what we do with CENGN Academy, and then we'll dive into the technical topic that we've got queued up. I'll give you a brief introduction to some high-level thoughts about infrastructure as code, what it is, what it's trying to do. And then we'll look at some tools that are commonly used for IAC, and what are some of the things you need to keep in mind if you are going to jump into IAC and start thinking about tools you want to use. And we'll follow that up with a live demo where you'll actually see a couple of different tools in use in a short but relatively real world kind of scenario. So CENGN is Canada's Centre of Excellence for Next Generation Networks. Our goal is to help everybody working in the Canadian ICT sector to do better. So that's both companies and individuals. We've got a program where we work with tech startups to help them test and validate their products and services so that they are ready for more rapid commercialization. And we've also got our training program. With that training program, we're looking to provide training in commercial leading edge topics. We always strive to provide practical value in our courses. And as CENGN does not sell its own products, you can be sure that we will bring an independent perspective to any of the training that we produce. Our goal, as I said, is to help you do better. We focus on self-paced training courses, but we also provide expert support along with that. So what do I mean? I mean that any course we develop from the beginning for self-paced online training. We put in labs and demos and videos. We target useful use cases. And we even inject error-based learning so you can skill up in important troubleshooting skills. But along with that, we provide high-quality learner support. While you are going through the course, pardon me, forgot to mention one thing. When I say self-paced online, you can access this training anywhere, anytime. Now, along with that, while you have your course access, if you have questions, you can ping us and we will respond. And most of our courses, we designate a couple of the hands-on labs where we ask you to upload your results to our learning portal, and we will give you actual feedback on it. So you're learning some of the practical skills with actual validation. And then finally, more formal learner validation. After you complete a course, you can have a checkpoint with one of our staff members, and you can qualify for one of our remote proctored exams. When you pass that, you will earn a digital badge that you can put up on your LinkedIn, on your resume, anywhere that you want. And as important as all of that is, it's also super important that we have the right course topic. So we have this, this gives us an overview of our training portfolio. We've got a DevOps course. We've got a couple of different Docker and Kubernetes courses. Our CENGN Cloud Systems Specialist covers a breadth of tools and technologies that you need to understand to be productive in a cloud setting. We've got a machine learning with Python course, infrastructure as code, and multi-cloud application deployment. And the content that we'll go through for the webinar gives you a small bit of what you will find in the full infrastructure as code course. If you want any more information about CENGN as an organization or about our training program, please go to www.cengn.ca. We've got lots of information about our partners, success stories with companies we've worked with. And over here on the left, if you click on Skill Up on the main page, you can get more information about our training services and our courses. And with that, let's jump into the real topic here. So, what is infrastructure as code? How does it relate to cloud computing? What are some of the goals of an IAC approach? What tasks can you automate? And what are some of the popular automation tools that are on the market? So what is it? Well, at its core, infrastructure as code is the management of IT infrastructure by writing and executing code files. We make use of machine-readable definition files to generate service components like virtual machines, networks, load balancers, etc. Think of it this way: anything that you can virtualize in a modern data center, you can then work with IAC tools to create and configure those kinds of service components. And a really cool thing is that because we're working with code files, you can use the same versioning and source control tools you use on any other source code within your organization. Now, how does it relate to cloud computing? Well, infrastructure as code was actually key to the birth of genuine cloud computing as we now know it. Virtual machines, of course, made it possible to run multiple separate servers on one single hardware box. But then IAC tools enable the rapid deployment of those virtual machines or whatever other resources based on user needs, which gives users, whether people or organizations, excellent elasticity of their infrastructure. Instead of working with a local operations team to get resources in local infrastructure, a developer can start a virtual machine, possibly on-prem, but also possibly on a cloud provider, start a virtual machine, use it, delete it within minutes, sometimes even seconds. This level of flexibility is one of the main reasons for the massive growth we have seen in cloud computing today. Now, cloud providers certainly have their own tools, but they have also recognized that users might want to use different tools. So they needed to implement existing IAC tools into their workflows. This means cloud providers have focused on creating systems that are predominantly API driven. API-centered cloud services allowed providers to use their own tools to monitor their internal infrastructure, while users can work with a vast selection of possible tools for provisioning and configuring. So this means that these resources can be created using API-centric tools or directly in the cloud provider's interface. Now, what are some of the goals of an IAC approach? There are lots of them. This slide lets us talk about 4 that are pretty significant. So IAC allows you to combine change with stability. It enables you to have an agile, responsive, but also stable infrastructure that meets the needs of both developers and operators alike. It makes change routine because IAC grants you the ability to apply and monitor changes quickly and easily and reliably because you're working with these code files. And in fact, most IAC tools are really strong on the documentation side. During the demo, we'll see that different IAC code files are highly readable. So that makes it easy to see what you're doing, and you can have a clear outline of what you've done to your environment. And treating infrastructure like code decreases the time needed to scale and also to respond to failures. And that allows operators to mitigate future outages better. Source control. Because we're talking about different kinds of code files, and we can use the same source control and versioning tools we use for application code files, we have an audit trail of the changes that have been done on your infrastructure. That allows you to have a clear understanding of how your infrastructure has and continues to evolve. And if for any reason something goes wrong, you can track back through this audit trail to find a stable spot that you can revert to and start again. And finally, productivity is another important goal of IAC because implementing these IAC tools alleviates the repetitive tasks that in the past have consumed so much time for IT operations teams, allowing them to focus on mission critical tasks as well as their own self-development. So then what kinds of tasks can be automated? A couple of important tasks we see here right away: provisioning and configuration. And what do I mean by these? So provisioning means the setup of these different virtual resources, whether virtual machines or networks or storage or containers. And operators can create reusable templates to set up these environments again quickly and reliably. So that's provisioning. Configuration is often the next step. You have a virtual machine, but you need to install and configure some kind of application on this virtual machine. And applications can be very complex with unique dependencies, ports, inputs, permissions, all kinds of things. Configuration management tools enable easy management of your applications regardless of their complexity. And they also give you the opportunity to check real-time application state changes and even get reporting on host state changes. Additionally, application deployment and orchestration can also be automated. Now, with application deployment, it's important to have automated testing during your application development lifecycle. IAC tools enable you to test both the application and the environment to ensure consistency on both levels and avoid breaking changes. And then orchestration. With the rise in microservice architecture, this has led to very complex applications spanning multiple hosts. Automated orchestration tools are therefore absolutely required to monitor and automate the application lifecycle across these distributed systems. So what can be automated? Provisioning and configuration actually are really key things, key types of tasks that we're going to automate. but there are others as well, such as application deployment and orchestration. On this slide, we've got a kind of a visual listing of a number of popular IAC tools, and let's start at the top middle with Terraform and Ansible. Terraform is a very popular provisioning tool. It can also handle some basic configuration. Ansible is a very popular configuration tool that can also handle some basic provisioning. And then also on the top row, Docker and Kubernetes. Docker is the key container runtime solution in industry. Kubernetes is the key container orchestration tool for managing and orchestrating massive deployments of containers. And on the bottom, we've got another collection of well-known tools in the market. Chef, Puppet, SaltStack. These are all interesting configuration tools. And Vagrant is a provisioning tool that's customized to work with VMware and VirtualBox and AWS and some of those kinds of cloud providers and virtualization machinery. We're going to focus primarily on Terraform and Ansible as we start working our way through the webinar and into the demo. Now, that's kind of a high-level look at what infrastructure as code is and what it's trying to accomplish. Eric, do we have any questions at this time?
I'm seeing nothing in the QA panel at this time, but everyone, as you feel fit, please type in a question here and we'll answer it at our next question period.
All right, thank you, Eric. Okay, so we've learned a little bit about what IAC is and what it can do for you. The next question is, okay, I am interested in investigating this. Which tools should I be considering? And if you wanted to get into depth, you would be looking at 10, 12 different considerations to think about. For the purpose of this webinar, I'm going to focus on these three, and these are three key things to think about when you're selecting your IAC tools. First, what kind of task are you trying to accomplish? Second, what communication method is used by the tool? And third, what type of language for scripting does your tool use? So let's take a look at these. As we said before, two key categories of tasks that you might automate are provisioning and configuration. And while there is some overlap that you might find between these two domains, for our purposes, let's think of them as separate. So we've got tools that are excellent for provisioning, and they are there to create virtual machines, create storage, maybe do some high-level modification of them, and then tear them down. So it's creation and removal of resources. Configuration management tools are used to install and manage software on these existing resources. So this could include things like rolling software upgrades, firewall rules, rolling back of application versions, different things of that nature. They can execute commands against multiple machines simultaneously, and that's a great advantage rather than having an operator sitting at a terminal working on each machine in a sequential fashion. Next, oh, sorry, one thing. Let me jump back here. You may find in your use case that you need to do some provisioning and some configuration, and that's kind of actually expected. And in that case, you might want to select one tool for provisioning and another tool for configuration. And that's totally fine. And in fact, that's kind of a best practice. You want to find the tool that really fits what you need to do best, rather than picking one tool and trying to force it to do things it wasn't really designed to do. Okay, communication, push versus pull. Both of these diagrams on the slide are representing a client-server environment. And in a push method, the controlling server pushes configurations out to destination systems. So in this setup, we use fewer computational resources and less networking resources because those resources are only consumed when the operator requests a change through the server and then pushes that out to the client nodes. In the pull method, the node or configured client machine requests updates or changes from the server. And it does that by periodically checking what's given as a configured or preferred state saved in the central server, and then it compares it to its own current state on the node. And if there's a difference there, it will pull a correction or an update from the server. So you can see immediately that this is kind of greater level of automation, but it also requires greater use of resources like CPU and network, and it also increases the complexity of the system. And finally, the language that we're using. And in fact, I mean like types of languages. So two major classes are procedural and declarative automation languages. Procedural languages are written to go step by step through a script without regard to the current state of the infrastructure. So every line is basically a do this, do this, do this. On the other hand, declarative focuses on writing what the desired end state should be, and then the tool takes care of the implementation. So every line in a declarative script is, this is my end goal, whereas in a procedural script, every line is, do this step. So our slide shows a couple of example templates here, one using Ansible and one using Terraform. And in both cases, we're going to create two instances on AWS, referencing an image type and an instance type and an image. Now you'll notice that in a very simple case like this, there's a lot of similarity in what you see. There's a count, there's an image given, and an instance type. And in both cases, if you start with blank infrastructure, if I run this Ansible script, it will create two virtual machines. And if I run this Terraform script, it will also create two virtual machines. So let's consider this scenario. You could take copies of both of these scripts and just change the count from 2 to 5, and now you have similar scripts, but they're designed to generate 5 virtual machines. So let's suppose that we have run the 2 virtual machine script from blank infrastructure, and then the 5 virtual machine script after that. And my question for you, and please put it in the chat, if we do that with Ansible, how many virtual machines do we end up with? If we do it with Terraform, how many virtual machines do we end up with there? So in both cases, on Ansible, blank infrastructure, the 2 VM script, and then the 5 VM script. Same idea with Terraform. How many virtual machines will we end up with? And I'll ask you to put your answer in the chat for a second. We'll pause for a second while people can put their answers in.
While we're paused to put the answers in, we did have one question come in when you're talking, I believe, about provisioning, and it's from Craig. Is there a particular tool set that works better for multi-tenant and heterogeneous environments?
So that's a good question. So I will say that I tend to like Terraform for a lot of things on the provisioning side. So that would kind of be my default answer. It is an excellent and very flexible tool. If you are working, honestly, in a particular cloud provider, there may be onboard tools there as well. But the thing with Terraform is not only is it flexible across different tasks, but you can also use it to do provisioning out on different cloud providers as well. Okay, so we've got a couple of answers to my question, and those answers are correct. With Ansible, you end up with 7. So we run the 2 virtual machine script, and then a 5 virtual machine script, it will generate 5. On the Terraform side, we run the 2 virtual machine script. And then remember, what the 5 virtual machine script is going to do is it's going to do whatever is needed to create 5. That's the end goal. So Terraform will end up with 5. Okay. So with that, let's head into our demo. And here's the scenario. I want to create a virtual machine. I want to configure the virtual machine as a web server. And I'm going to use the Nginx web server package, but I want to do this with some customized content. Then I'm going to containerize this web server. So what I mean by that is I'm going to pull down the standard Nginx container image from Docker Hub. And then I'm going to destroy the virtual machine. So I've got some provisioning work here, and I've got some configuration work as well. For my tools, I'm going to use Terraform to do the provisioning. So that's the creating of the virtual machine and the tearing of it down. For the configuration work, I'm going to use Ansible. So the high-level process looks something like this. For provisioning, I need to use Terraform to create a virtual machine, but it's just a virtual machine when I'm done with Terraform. Now I need to do the configuration with Ansible. I'm going to run an Nginx installation script, and it's going to pull in some custom content as part of that script. Then I'm going to run a Dockerization script, which involves stopping my existing Nginx server, installing Docker, and then pulling down and running the standard Nginx container from Docker Hub. And then after all of that, I'm going to destroy my server virtual machine, again using Terraform. So let's take a look at how this will work. So I am going to be doing all of this on CENGN's private cloud, and we are going to be using OpenStack as our cloud management tool. So you can see that there's a lot of instances already created on our infrastructure, but what I want to do is keep focused on an instance that we're going to call webinar server. So keep that in mind. Now, this is my controller server, and I'm into a folder called webinar demo. So let's take a look at what is there. I've got an HTML folder. That's where the custom content is going to come out of. I've got 3 YAML files. Those are all going to be part of the Ansible portion of this demo. And then I've got a part 1 directory. And so let's jump into that one and take a look at what might be here. So you can see I've got 5 files. I've got a main.tf, provider.tf, variables.tf, and a couple of tf state files. So for now, let's focus on main, provider, and variables. These are key files for actually running the Terraform script that I want to do. So let's cat the main file and take a look at this. So this is a very simple main file. With Terraform, you can get quite complicated in what you're doing, many different things in a single file. For us, we are going to create a virtual machine. But you'll see that a lot of the parameters here are listed as variables. So this is kind of borrowing good practice from regular programming, where you don't want to hard code variable values into your program. So what we've done here is we've listed, you can see here, we've listed variables, and then we've got a variables file. So we can see our variable name is going, the name of the VM is going to be webinar server. Size or the count is defaulting to 1 unless I make a change when I call the script. I'll also point out this part here, variable, the image. So the image, this talks about what operating system I want to be installing onto my machine. And you can have multiple lines here. And what we've got is an opportunity to have a couple of things kind of ready to go, depending where I want to spin up this particular virtual machine. So the line that's all commented out, that would be on our Communitech data center in Waterloo. The one that is active is going to spin up a virtual machine on our Bayview Yards data center. So you could have a number of different things in each of these categories, and then before you actually run the script, comment out the ones you don't want to use. And so you can keep using the same file and have it do different things depending on what's commented out and what is active. Now, we also had a provider.tf file. I'm not going to dive into that because that's a little bit more technical and harder to understand. But the point there is that provides all the information to allow Terraform to talk to the given cloud provider, in this case, OpenStack. Okay, so how do we work with Terraform? We've got these files. How do we make them work for us? Well, Terraform likes to use a very simple 3-step workflow: Terraform init, Terraform plan, and Terraform apply. So we're going to start with Terraform init, and this is going to initialize our connection to OpenStack. So everything came up green. That's good. Terraform plan basically kind of does a dry run through what's listed in the main file. And it gives you output to say, this is what I'm going to do. So a couple of things that we kind of should recognize from the variables file: webinar server is the name. The plan is to add 1. And then some other things will only be known after the full apply. For example, the IP address will only be known after applying. So this step gives you an opportunity to review all of the things that Terraform is going to do, make sure it aligns with what you think Terraform should be doing for you. If there's a difference, you have an opportunity to go back and make changes and then come back. In our case, it's all good. So then let's go with Terraform apply. Now, interestingly, it's going to show you the same thing again, the same output. One more chance just to confirm or bail out of doing this. Do I want to perform these actions? Yes, I do. So I type yes. So it's connecting to my OpenStack. And if I go over to my OpenStack, I can see this instance starting up. So it's spawning, and it, if all goes well here, oh, wow, super quick. So that virtual machine started up in literally seconds. And you can see the green right there. Everything is great. So we have a virtual machine up and running. Now let's go back to the main folder and again, take a look at these YAML files. The YAML files are the ones we're going to use for the Ansible configuration tasks. I want to look at inventory first. The inventory gives me a listing of IP addresses that I'm going to do my configurations against. So I need to go back over to OpenStack. And in fact, the correct IP address is .18. Okay, so I can make a quick edit here, save this. now I've got the inventory file pointing in the right direction. So the next step is a command, Ansible playbook. Whoops, I needed a dash in there. I thought there's my dash. -I have to tell Ansible playbook what inventory file I want to use. And then what I'm going to do is I'm actually going to start the script running. And then we'll take a look at what's actually inside the script file, because it takes a couple of minutes to do everything. So let's start this running. And then over in this window, let's take a look at this file. So there's a fairly standard structure to an Ansible file. At the top, we see this hosts all. This means I am going to perform all of the listed tasks against all of the hosts in the inventory file. And then we have a number of high-level tasks. We name it, there's some information about each one. So the first task is going to be installing Nginx. Next step is to copy over the updated HTML files. And then finally, of course, we have to start Nginx running. So again, I mentioned readability is important with IAC, and you can see this immediately. We can give a nice description in the name. And then for installing Nginx, because I'm working with Ubuntu, I'll be using the apt package manager. Next, copying over updated HTML. It's just like it looks very readable. It's a copy command. And then to start Nginx, it's listed as a service task. There's the name of the service and the state should be started. Now, the other thing that I'll point out is this line here that you see 3 different times. Become yes. This is Ansible's way of saying, I need to be root in order to run this particular task. Now, it's interesting that we've got become yes for all 3 tasks. So you might think that it would make more sense to actually just put the become yes kind of up here. But best practice with Ansible is you only become root when you absolutely need to. So best practice is for each task that you need to become root for, that's where you put become yes, even if you have to do it several different times. Okay. So then I want to shift over to this other virtual machine. This one has a GUI, it's got a web browser available to us. So let's take a look. Our IP address should be 10.169.177.18. And there you go. We've got a nice customized web page running from Nginx. Eric, I see there's a question. Is that one that is good to answer right now, or should we save that one for a little later?
No, it seems that it's a perfect time to answer it now, as it does pertain to what's going on. And it's can a manage node ask the control node to run a playbook on it?
So I want to answer this in 2 parts. Number one, that's not the normal thing that you do. So it's not that's almost a pull kind of a methodology. That the standard way that Ansible works is it's more push oriented. So you work from the Ansible control node and push configurations out to the different nodes. Whether or not it actually can, I'd need to check on that. So Eric, let's do this. After the webinar is over, I'll just cycle through make sure I've got the absolute correct answer on that, and then we can get that out to the participants.
That sounds great. Thank you so much for that. Yeah, we will. Yeah, we'll find a way to get that out to everybody.
Okay, great. All right, so we've used Terraform to create a virtual machine. We used Ansible to start Nginx running on it. And then the next part of the demo is to, well, it's another script. I want to Dockerize this. So I'm going to start this running. And again, then we'll go over to the other terminal window and take a look at what's actually in the file. So we'll get it going. And let's cat part 3 and take a look at what's here. So again, it's a longer file, but the structure is somehow similar. We've got a line telling us hosts all. So again, I'm going to do whatever's listed below on all the hosts in the inventory file. And by the way, we skipped over it, but the implication here is that I could use Terraform to spin up 5 virtual machines. If I put all 5 of those IP addresses into my inventory file, when I run this script, it will simultaneously do all of this work on all 5 nodes. So that's a nice thing that you can do. Okay, so we've got a number of tasks here. The first one, and you can see some of them have already been done over on the other display. So I need to stop Nginx. That's a service task. I need to install Docker, which has already been done, and then install pip. Pip is the Docker module for Python, so we need that. Next, and it's still installing, but it's once it gets that done, it'll start rolling through everything else really quickly. I need to set some permissions. I need to create a Docker group and then add the Ubuntu user to the Docker group. The point of that is so that when I'm logged in as the Ubuntu user, I can now run Docker commands. And then the last thing is to actually, so we downloaded and installed the pip package. Now we actually need to get it running. And finally, I'm going to deploy Nginx as a container. So this command will go out to Docker Hub. It will download the standard Nginx container image and start it running. So that's exactly what you can see has happened over here. We've gone through all of these different things. There were 9 different tasks. 9 have gone through. What changes have I made? I've made 7 different changes compared to what I had before. So let's actually take a look here. What should have happened now is that this web page should look different, because in the initial step, we made a point of including custom content. Now we've pulled down the standard Nginx container image and started that running. And that's exactly what's happened. This is the absolute standard default welcome page when you're running Nginx. So we've been able to be successful. So what have we done? To recap, we've used Terraform to create a virtual machine. We used Ansible to install Nginx as a regular service. And then we installed Nginx as a container and started running that. Now the last step is to use Terraform to tear down this virtual machine. So I need to go back into my Terraform directory, and let's take a look at what files we've got once again. Now, when we first looked in this folder, I skipped over the TF state files, but now is a good time to take a look at these. These files record the state of what Terraform has just done, the current state of the infrastructure according to Terraform. So you can see a lot of things. Some of the values here you should recognize from the initial files. Webinar server is the name of our server. There's that IP address that we can confirm. Remember that Terraform is declarative. When you give it a file and instructions, it will take those instruction files as the target result. So it needs to understand the current state of the infrastructure. And that current state of the infrastructure is shown and recorded in the TF state file. This, of course, means that when you're working with Terraform, you need to protect your state files. You can't let anybody just edit them, because then Terraform will have no idea what to do with anything. And you need to make sure you don't lose them. So the TF state file is super important for Terraform to work in this declarative fashion. Now, the last step then is Terraform destroy. This is the command. So this means Terraform, go ahead and destroy everything that you created that is currently listed in your TF state file. And in fact, it will show you a display and give you the option to confirm that you really want to do this. Do I really want to destroy all these resources? Well, in this case, yes, I do. So it's destroying it. Let's browse over to OpenStack, and it's gone. And we'll see here, yes, completely gone. And just to confirm one more time, let's go back over to our web browser. And if I do the Control-R to do a complete reload of the web page, not from the cache, you can see here that it's thinking, because it can't find that the server is gone. And that's the demo. So we've been able to do everything that we wanted to do. You'll recall that the goal was to use Terraform to create and destroy infrastructure, and to use Terraform to configure it in a couple of different ways, and we're able to do that. We're able to look at the high-level process for how Terraform works, get a feeling for what an Ansible script looks like. Yeah, kind of a little fun little demo there. Gives you an idea of what you can do using IAC tools, and also the difference between a provisioner like Terraform and a configuration management tool like Ansible. And that's the end of the demo. Are there any final questions?
So as we said in the opening, if there are any questions, please use either the QA panel here, or please raise your hand in the participants tab, and we can unmute you if you'd like to ask a question live.
And while you're doing that, I'll remind you once again, www.CENGN.ca if you want more information about what we're doing as a whole company, or about our training program in particular.
Well, thank you for that, Peter. That was a fantastic presentation. Many people already thanking you in the chat, which is great to see. I'm seeing no questions coming at the moment, so I'm going to give a little bit more time for them to come in as we wind up today. But Cynthia, if you'd like to finish us off here, I'm going to share our ending PowerPoint.
Thank you, Eric, and thank you, Peter. That was great. We really look forward to your next presentation for our community as well. A quick update. There was a bit of an error on our first slide when we introduced our 4 new booster packs for you. The blockchain DLT for smart contracts, that is being brought to you by a company named Sanofi. So apologies for the mistake there. And as I said, look forward to getting more information about all of these companies and their booster packs that they're being built for you. So again, just a quick moment I'm going to take to remind folks we are looking for new booster pack builders. There is a lot more information available if you reach out to me directly, but quick benefits about becoming a booster pack builder, the connections to potential partner and resources. We do invest quite a bit of time promoting the companies that we've selected and their products and the work that they're doing for us. So great opportunity for exposure and recognition, and they're paid. We pay for your time and your contribution. It's a $50,000 fixed price contract for anyone that's selected to build a booster pack for us. And if you're interested in more information about what that means, please do check out our website. It is an online application. And if there's any other questions about that, or anyone has a suggestion about a booster pack that you'd like to see us build, we're also very much interested in what is it that you folks want to see out there in our community. So if you have any thoughts and ideas on that, also feel free to reach out to me directly with your feedback. And I think that brings us to an end today. If there are any other questions, we'll just take one more moment to Eric, but I think you've answered them all for us. Peter, Eric, I think we're good.
Yeah, I'm not seeing any others come in at the moment. Again, last minute for anybody who would like to ask another question, please do so in either the QA panel or by raising your hand in the participants tab. But I think that will be the end of the webinar today.
Great. Well, thank you, everyone. And as Peter said, if you'd like more information on the CENGN Academy, it's a fantastic program. So do feel free to also reach out to him directly for more information on that. And with that, I wish everyone a great rest of your day. Thank you.